Hey guys, welcome back to AlgoYogi. We are doing linked list series. Our next problem in the list is remove nth node from the end of the list. So let's visit the problem on LeetCode, and it's one-liner. The description is one-liner, not the solution. So given the head of a linked list, remove the nth node from the end of the list and return its head. This is remove nth node from the end of the list. It's not the from the beginning of the list, not the nth node from of the list, which would be considered from the beginning. It's from the back of the list. Always remember that. Sometimes people read it and it's like, oh, nth node, and let's just start removing it, instead of even realizing that n given here is 2, and it's basically from the back. Fourth node is from the back, basically. So let's see how we're gonna do it. We can do it few ways. One is take this list, convert it into an array, and basically remove the nth node from the back, take it off, take the rest of the array, convert it to list, and return it. But that's of course not the best solution because we are dealing with the extra space here, so we're not going to do that. What we're actually going to do is, we know that we need to remove the nth node from the back of the list. How about we try to find what is the node, what is this n from the beginning of the list, right? So it would be basically considering the length of the list. In this case it's 5, and 5 minus this n will give us 3. So it's the 3 plus 1, because we are our head is already on the first node, so 3 plus 1th node that we need to remove. So this is the fourth node that we need to remove. All right, so how are we going to calculate it? Just find the length of the list and subtract the n, then we get whatever node that we need to remove. So in this case we're getting the fourth node that we from the beginning that we need to remove. But also remember that when we are traversing towards that node, it's not that node that we want to reach to. We want to reach one node before that node, so that we can set the pointer instead of next to next dot next. All right, so I think it's really easy solution. First is finding the length. So I'm going to call it list list length initially being 0, and then curve pointing to head, and oh my god, why am I using this? Curve pointing to head while curve. So I'm gonna increment list length, and that is +1, and then curve pointing to curve dot next. All right, now we have the list length. What if the n is equal to the length of the list? That means we want to remove the head. So if my n was 5, and we have basically in this example, I'm gonna just change the view here. So what if the n is equal to 5? N is equal to 5. This is the fifth node that I need to remove from the back. So the 1 is what I need to remove, and my length of the list is also equal to 5. Then I get the node that I need to remove is basically 5 minus 5, and the node that I need to reach to remove that is -1, so which is basically getting to -1. That's not what we want to do. If let's say I want to calculate it like m from the beginning, so m equals to list length minus given n. So if m is basically less than, I would say 0, then I would say, or you know what, I'm just gonna just do it. If my list length equals to n, return, what do I return? I will return head dot next. All right, otherwise what I'll do is basically have current pointing to head. Again, I know I'm reusing cur, but it's okay. While no, not while m is greater than 0, and also I have to basically subtract 1 because I want to reach one node before that rather than at the that particular node, you know, not the fourth node. I know it's like in this example it's 3, but I know since I'm already on head, then moving 2 pointers will take me to the third node, or moving 3 pointers take me to the fourth node. So that's why I'm subtracting 1, although the value is 3. But then I think you would understand when you write the code. You would understand like where it's taking you. Make mistakes, make absolute bangers, but understand why, you know, understand the why behind it, and you will once you make the mistake. Okay. Enough of gyan. Current is pointing to head, m is greater than 0. Then I want to move my current to cur.next, subtract my basically m, and once I come out of here, I will be pointing to the node third node over here. This is what I'll be, oh my god, come on. This is what I will be pointing to, and from here, if there might be some case where it's already none, or it's already like it is the last node. So in that case, I need to check, or it does not have any node after that. So I can't point cur.next to cur.next.next. I can only do it if current exists and cur.next exists. So then I can do cur.next equals to cur.next. So this could come as none, and this could come as some, basically some value that it's the current's next that I need to point to. So this has to exist. This is what we're gonna remove, and all right, then we just return head. All right, we just return head. All right, let me zoom out and see if this runs. It does. Submit it. Hopefully it will be submitted. I'm gonna just start writing the time complexity, which is big of n number of nodes. Worst case, we're traversing all the nodes if we're removing the first node, because we need to find the length of the list. Space complexity would be big of 1, because we're not really storing. I already discarded the approach where we're gonna use the array and remove that particular index from the back and then create the list again. But that's what not we did. That's not what we did. I think so. Yeah. All right. Let's go back to AlgoYogi. Mark it solved. See you guys in the next problem. Until that, bye bye.